Hi, I'm Per Sedihn, the CTO of Proact. This time I'd like to show you what's happening with the storage media of the future, solid-state storage. Solid-state storage will change how we store information over the next few years. And right now, in 2010, it's the way for storage architects to make some really good friends among application owners and users. You have some really cool new building blocks to play with. I will give an overview of the architecture and also show how it's being implemented today. Solid-state storage is a design based on memory chips that are packaged to look and feel like a disk to the outside world. This is to make it easy to integrate in today's storage architectures. Under the hood, you will have to know how these things are built because they're not all the same, and it does affect their performance, availability and price. What everyone is talking about today, and what will most likely grab big volumes in the market, is flash memory devices. Flash is what we use in all our domestic devices today, and some of these enterprise storage devices are based on that exact technology, called MLC. There is also another faster and more reliable version of flash called SLC. The first piece of advice is to use the SLC version for your data center. But we are already seeing vendors mixing these two types and trying to manage the weaknesses inside the devices. There are limitations in the number of writes you can do to flash memory, and it's much faster at reading than writing, although it's still faster than a spinning disk. For years, we have seen DRAM packaged as storage devices. They are very fast and very expensive. The future here lies in using them in storage devices where you mix flash and DRAM for optimal performance. So, what is really the problem with spinning disk of today? The answer is IOPS per second. In 1981, a typical disk could do 20,000 IOPS per gigabyte. But today, a disk is capable of only around 0.5 IOPS per gigabyte, and this is causing problems. For I/O-hungry applications, we are not able to keep up with their needs. We are seeing these applications suffer from poor performance and poor response times. If you have these types of application, it's time to analyze your I/O patterns and look at solid-state storage as an alternative. By using solid state, you will get a new storage tier to work with. And since tier 1 is already occupied by Fibre Channel and SAS, we call this tier 0. The most important work today is to make sure we have the right information at the right time in tier 0. We want active data with a high change rate here. If we end up with old static data, we have spent a lot of money on nothing. A good idea is to work together with the application owners to identify application or parts of applications that are well suited for solid-state storage. Remember that high IOPS with more reads than write is a good starting point. The storage industry will provide you with some different ways to implement them, and here's a short overview of the 4 major types. Put the PCI card in the server bus. It's close to CPU and memory for good performance, and it's relatively inexpensive. It's a specific solution for an application, and you can't share it. And you might also break the backup recovery and disaster recovery processes you created on the central storage, so keep that in mind. Add SSD devices to your existing storage array if it's supported. You'll get a well-integrated solution where in some cases you can use built-in tiering in the disk controller to move data in and out of tier 0. You will of course need a disk array supporting this, and the control in the disk will be the bottleneck and limit the full performance of the SSD devices. Use a dedicated solid-state storage array that you attach directly to the servers that need high performance. It can be shared, and with a combination of flash and DRAM it would really fly. It's pricey, and you get another device to manage in your storage infrastructure. Tier 0 integrated within the file system gives you a very adaptable and flexible solution in your file servicing environments. It requires a file system that can move between tiers of storage devices, and there are just a couple of choices on the market today. Whichever solution you select, start by doing your homework, and you will be able to work some magic for your users. And that doesn't happen every day, at least not for me. So the primary usage today is to increase the speed of application where the storage infrastructure is the bottleneck. In a few years, we will see the price come down to where fiber channel drives are, and solid-state disk will replace high-end drives in 3 to 5 years. A few more years down the line, they are very likely to replace spinning disk in all use cases. They will be the same price, consume far less power, and give you better or similar performance for any kind of usage. Until next time, live well and store wisely.
Yeah.